Okay, another short lecture. We're going to talk about properties of matter. There's two ways we can talk about properties. One is intensive versus extensive properties. The difference between intensive properties are those properties that do not depend on the sample size. Good examples of this would be temperature. So it doesn't matter whether I have 1 gram of water or 10 grams of water. If the temperature is 20 degrees Celsius, it doesn't matter what the sample size is, okay? Color. Sulfur is yellow no matter whether it's 10 grams or 20 grams. It doesn't matter. Melting point. So water melts at 0 degrees Celsius, whether that's 1 gram of water or 10 grams of water, doesn't make any difference. Same goes for boiling point. Density, same thing. Density relates the mass of an object to its volume, but 10 grams of water has the same density as 20 grams of water. It doesn't matter. Extensive properties do depend on the sample size. So volume of water would depend on the amount. 10 grams of water is going to have a different volume than 20 grams. Length, like a 10-inch cast iron pan is going to have a different length than like an 8-inch cast iron pan. So with less material in there, it's going to be a shorter length. Mass, same thing. 10 grams obviously is a lower mass than 20 grams of water. So that's the only difference between intensive and extensive. It's a pretty simple distinction. One depends on the sample size and the other one doesn't. Okay, physical properties and chemical properties. Physical properties are pretty easy to understand. So physical properties don't involve any sort of chemical change or chemical aspect to the property. For example, temperature. When I take the temperature of water, I'm not doing anything chemically to measure that temperature. It doesn't depend on the chemical makeup of water. Color, same thing for sulfur. Sulfur is yellow, and that's a physical property. Okay, nothing chemical is being changed when I note the color of sulfur. Melting point, same thing. In fact, this one's could be confusing if this is your first chemistry class ever. Melting point is the temperature at which a substance transitions from a solid to a liquid. And in that melting process, even though it seems like it's chemical, it's not chemical, actually. That's purely a physical process. When solid water or ice melts, there's no change in the water molecule structure. It's H2O solid transitioning into liquid water, no chemical change to the water itself. It's still two hydrogens glued to an oxygen, H2O. Odor. Okay, so that is a physical property. Hardness is a physical property. So those are pretty easy to understand. Chemical properties are a lot harder to understand. It takes a lot of experience and intuition about these things, but I'll give you an example of a chemical process or chemical property. Oxidation potential for metals, like a rusting of iron. Okay, when iron rusts, it transitions from iron metal, so just Fe only from the periodic table, and it transitions into iron 3 oxide, a different chemical. That is a chemical change that's occurring when this reacts with this to produce this. This starts as a solid, this is a gas, and then this is all solid. Okay, this is not balanced. I better do that. Okay, so that is a balanced chemical equation. The matter that we started with, iron, transitions or transformed into a different substance. That's a chemical change. Remember, chemistry is the study of the properties of and the transformations of matter. This is a transformation of the chemical structure of iron and oxygen to produce this. Now, on the test, I'm going to present this equation and just simply ask you, was this a chemical change or a physical change? The fact that iron transitioned from iron to this, automatic, it's a chemical change. You see a change in the structure. Versus melting, I would present this on the test. I'd say H2OS and then H2OL, which implies melting. Notice that there's no change in the chemical structure of water. It's water here and it's water here. That's purely a physical change. Chemical change, physical change. Okay, and that's how you're going to tell the difference if it's a test question. Was there a change in the chemical structure or not? Okay, I think that's it for this very short section. So that covers, I think that's it for week one material. I'm recording this in the spring 2026 semester. So unfortunately, we are not meeting for the first week here. So it's lucky that these 3 first lecture videos are really short. Okay, but you do have to get them done nonetheless. Okay. But otherwise, that is it until we start talking about measurements.